This is the EdExcel GCSE Maths paper 9-1, paper 1 from the higher tier, and it's from the November 2019 series. So let's get straight into it. Question 1, we have to find the lowest common multiple of 108 and 120. So to do this question, I think it's easiest if you split this up by considering the prime factors of 108 and 120. So if we consider the 108 first, we require over here two numbers which multiply to give 108. We have 2 and 54. 2 is a prime number, 54 isn't, so the 54 we can further split up into 2 times by 27. 2 is a prime number, 27 isn't, so we can split the 27 up into 3 times by 9. 3 is a prime number, 9 isn't, so we can split the 9 up into 3 times by 3. And if we do a similar thing with this 120, we can split the 120 up into 2 times by 60. 2 is a prime number, 60 isn't. 60 we can split up into 2 times by 30. 2 is a prime number, 30 isn't. 30 we can split up into 2 times by 15. 2 is a prime number, 15 isn't. 15 we can split up into 3 times by 5. And now that we've decomposed the 108 and the 120 into its prime factors, to find the lowest common multiple, first of all you'll notice here we have a 2 which is common to both. We also have another 2 which is common to both, and we also have a 3 which is common to both. So if we multiply these together, 2 times by 2 times by 3, this over here will find for us the highest common factor. And then for the lowest common multiple, we multiply the other numbers that are left over. So we've got the 3, this 3 here, this 2 here, and this 5 over here. So if we work this out, you can see here 2 times by 2 times by we'll leave it as this. 2 times by 2, that's 4. 3 times 3 times 3, that's 9, 27. 2 times by 5, that's 10. So over here you can hopefully see we have 4 times by 27, which is 108. So here we have 108 multiplied by 10. So the lowest common multiple is 1080. So let's just write that down for our answer. We have the lowest common multiple being 1080. Question 2. There are 60 people in a choir. Half of the people in the choir are women. So if half the people in the choir are women, this tells us that 30 women are in the choir. The number of women in the choir is 3 times the number of men in the choir. So the number of men is going to equal 30 divided by 3, which is 10. So there's 10 men in the choir, and the rest of the people in the choir are children. And the number of children in the choir to the number of men in the choir is in the ratio n to 1. We have to find the value of n. You must show how you get your answer. Well, if 30 women are in the choir and there's 60 people altogether, that means that there's 30 people who are children and men. And we know of those 30, 10 are men, so therefore 20 are children. So we have 20 children, 10 men, 30 women. This gives 60 people in the choir. So the ratio of children to men, that's equal to 20 to 10. And if we write this in the form n to 1, so we want a 1 over here, dividing through by 10, 20 divided by 10, that's 2. So you can see over here n is equal to 2. For question 3, we have to work out 1 3/4 times 1 1/3, give your answer as a mixed number. I think the first thing you can do is rewrite this as a top heavy fraction. So here, if we do that, let's just draw our lines. We have 1 times by 4 plus the 3 over 4 multiplied by 1 times by 3 plus the 1 over 3. So you can see over here we have 4 plus 3, that's 7. So we have 7 over 4 multiplied by, here we have 4 over 3. And you can hopefully see here the 4's cancel, so we are left with 7 over 3. And this as a mixed number, well, 3 goes into 7 2 whole times, and what's left over is 1. So we have 2 1/3 as our final answer. Question number 4. We have to use a ruler and compass to construct the line from the point P perpendicular to the line CD. Well, if we grab our compass as shown here, extend it out, put the pointy bit at the point X over here, and literally intersect this line CD with a couple of arcs. So if we do that, we can intersect it here and also here. So we've got 2 intersection points. We've got one here, we've also got another one here, and now from this we can draw a perpendicular line, put the pointy bit over here, and then draw a arc like so. Draw one on the other side, keeping the same length, put the pointy bit over here, and again intersect like so. And then all you have to do is join these up with a straight line. I might have messed up a bit, but that's the idea. We have a perpendicular bisector as shown here. Okay. Question number 5. We've got the diagram over here which shows triangle ABC. ADB, that's a straight line. The size of the angle DCB, that's this angle here, to the size of the angle ACD, that's this angle here, that's in the ratio 2:1. We have to work out the size of angle BDC. So for us to do this question, we want to work out this angle over here. Let's just call it Y for now. So we want to work out this angle Y. And for us to work out this angle Y, we already know that the angles in a triangle add up to 180. So the angles in the triangle BCD add up to 180. So we need this angle somehow. Well, we were told in the question the ratio of this angle to this angle is given. So if I call this angle X, this angle over here will be 2x. And you can see here, these angles are in the ratio 2:1. So if we find out what X is, we can use this information to find out what 2x is, and using the fact that angles in a triangle add up to 180 to find out what this angle Y is. So if we consider the triangle ABC, we have 75 degrees plus 51 plus there's 2x plus x, so plus 3x. This is equal to 180 degrees. And if we tidy this up a bit, we have 126 plus 3x equals 180. And if I subtract 126 from both sides, you can see here 3x is equal to 57, and dividing both sides by 3, x is equal to 18. So if x is equal to 18, 2x, this angle over here will equal 2 times by 18, which is 36 degrees. Now why is that useful? Because if we consider the triangle BDC, we have the angle Y, plus 51 plus over here this 36. So we add on this 36. All of this is equal to 180. Again, angles in a triangle add up to 180. So here we have y plus 87 equals 180, and if I subtract 87 from both sides, y is equal to 93. So the angle we require is 93 degrees. Question 6. 4 red bricks have a mean weight of 5 kilograms, 5 blue bricks have a mean weight of 9 kilograms, and 1 green brick has a weight of 6 kilograms. Donna says the mean weight of the 10 bricks is less than 7 kilograms. Is Donna correct? You must show how you get your answer. Well, we can use the fact that the mean is equal to the sum over the number of data points. So this is something worth memorizing. So we can use this to find out the total weight of the red bricks, the blue bricks, and the green bricks. And then from that we can find out the mean of the 10 bricks in total. So the total weight of the red bricks, that's equal to, well, here we have the mean 5 times by n, that gets us the total. So we have 4 times by 5, which is 20. So all the red bricks weigh 20 kilograms. For the blue bricks, we have over here 5 times by 9, which is 45 kilograms. So all the blue bricks weigh 45 kilograms in total. And for the green bricks, 1 times by 6, that's 6. So the green bricks in total weigh 6 kilograms. So therefore, the total weight of all the bricks, we have 20 plus 45 plus 6. It turns out we get 71 kilograms for all the weight of the bricks. And therefore, the mean of the 10 bricks, that's going to equal 71 divided by 10, which is 7.1 kilograms. And clearly, this is greater than the 7 kilograms, and therefore, Donna is incorrect. Question 7, we have to simplify p squared to the power of 5 for part A. So, if we do this, we can use the fact that a to the power of m to the power of n, this is equivalent to a to the power of m times by n. So we multiply the powers. So p squared to the power of 5, that's the same as p to the power of 2 times by 5, which is the same as p to the power of 10. And now for part B of the question, we have to simplify 12x to the 7 y to the 3 divided by 6x cubed y. Well, I think it's easier if we write this as a fraction first. So on the top we have 12x to the 7 y cubed, and on the bottom we have 6x cubed y. And we can use the rule that tells us a to the power of m divided by a to the power of n is the same as a to the power of m minus n. So if we use this, well, 12 divided by 6, that's equal to 2. 7 x to the 7 divided by x to the 3, that's the same as x to the power of 7 take 3. And then here we've got essentially y to the power of 3 divided by y. Well, why is that the same as y to the power of 1? So here we have y to the power of 3 take away 1. So if we tidy this up a bit, we have 2x to the 4 y squared. So we have 2x to the 4 y squared. Question number 8. The accurate scale drawing shows the positions of port P and the lighthouse L. So we've got the port P over here, the lighthouse L over here. We've got a scale, 1 centimeter represents 4 kilometers. Alina sails her boat from port P on a bearing of 70 degrees. She sails for 1.5 hours at an average speed of 12 kilometers per hour to Port Q. We have to find the distance in kilometers of Port Q from the lighthouse L and the bearing of Port Q from lighthouse L. So to do this question, we'll first of all deal with this bit of information here. She sails on a bearing of 70 degrees from P, so if we grab our protractor, align the crossover here on the line here with the straight line shown in the diagram, and mark off 70 degrees. And if we now join these up with a straight line, we have something looking like this, okay? So now, if we use speed equals distance over time, we can find the distance from P to some point Q. So we know that speed is equal to distance over time. So the distance over here, that's equal to, if I write this down, the distance is equal to the speed, that's 12 kilometers per hour, multiplied by the time, which is 1.5. And if we multiply these together, it turns out we get 18 kilometers. So we need to know that Q is 18 kilometers from P. And if we use our scale, of course, dividing by 4, well, if I divide by 2, I get 9, and if I divide by 2 again, I get 4.5. So we have over here the point Q here. And our job is to find the distance from Q to L. So if we measure this distance Q to L, you'd find over here the distance QL, that's equal to 5.5. So if we write this down, Q to L is equal to 5.5 centimeters, and if we use the scale, multiplying this by 4, so 5.5 times by 4, that's 22. So it turns out we get here QL is 22 kilometers. And now if we find the bearing of port Q from the lighthouse L, first of all we need to join these lines up, these points up rather, and if we join the points up, we can now find out the bearing. And if we work out the bearing, so align everything up like so, it looks like the bearing over here, if we make sure we're on 0 degrees first, the bearing is looking like over here 323 degrees. So it turns out over here we get 323 degrees as our bearing. Question number 9. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in these 18 minutes? Well, if you look at the units here, we have kilometers. And what you should know is speed is equal to the distance over the time. We're looking for the distance, so we multiply the speed by the time. But over here, we've got 18 minutes, and here we've got 72 kilometers per hour. So we need to convert the units for consistency. So to convert from minutes to hour, we would have to divide by 60, and to go from hours to minutes, we have to multiply by 60. So if we do that, 18 minutes, well, what we can do over here is divide 18 by 60. So 18 divided by 60 hours is how long the car is travelling for. So over here, the distance, that's equal to the speed, 72 kilometers per hour, multiplied by the time, which is 18 over 60 hours. And hopefully here you can see the hours essentially cancel. So 18 divided by 60, well, if I divide the top and bottom by 6, here we have 72 times by 3/10. So it turns out over here we've got 7.2 times by 3, which is 21.6. So over here we have 21.6 kilometers. Now for part B of the question, David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? You must show how you get your answer. Well, for this question, we need to make sure that the units are the same and then compare. To go from, if we write this down in full, to go from kilometers to meters, we would have to multiply by 1000. Meters to kilometers, we would have to divide by 1000. And also, to go from hours to seconds, we would have to multiply by 3600. Seconds to hours, we would have to divide by 3600. So if we take a look at the 72 kilometers per hour, we can convert this into meters per second. First of all, if we multiply by 1000, we have meters on the top, and if I convert the hours into seconds, after times by 360, so here we have 3600 seconds. So working this out, it turns out we get 20 meters per second, and of course they are the same, so therefore we can conclude that David is incorrect. Question number 10. The cumulative frequency table shows information about the times in minutes taken by 40 people to complete a puzzle, and for part A we have to draw on the grid below a cumulative frequency graph for this information. Well, over here at 40 minutes we have a cumulative frequency of 5, so let's just add this on here. And then 60 we have 25, so 25, that's over here. And then for 80 we have 35, so 80 we have 35 over here. And then 100 we have 38, so 38, that goes here somewhere. And then 120 we have 40. So now our next job is to join these points up with a smooth line. So we have something looking like this. And now for part B of the question, we have to find an estimate for the interquartile range. Well, the interquartile range, that's equal to the upper quartile minus the lower quartile. So we've got over here 40 people in total, so the lower quartile, that's going to be 40 divided by 10. Sorry, 40 divided by 4, which is 10. So the lower quartile, that's equal to, well, here we've got 45 by the looks of it. So what we have over here is the lower quartile being 45 and the upper quartile, well, lower quartile times 3, so 10 times by 3, that's 30. So if I draw a line across from 30 and then draw a line down, we have over here 69. Okay, so here the interquartile range, that's equal to 69 take away 45, so that is equal to 24. So here we've got 24 minutes. And now for part C of the question, one of the 40 people is chosen at random. We have to use the graph to find an estimate for the probability that this person took in between 50 minutes and 90 minutes to complete the puzzle. So 50 minutes to complete the puzzle. If we work this out, so 50 minutes, that's here, and drawing a line up and then drawing a line across, you can see that's drawn that completely incorrectly. So drawing a line up from 50 and then drawing a horizontal line across, you can see here we've got 16 who took 40 or less. So we've got here 16 and what was the other one? Between 50 and 90 minutes. So 90 minutes, that's over here. So if I draw a line up and then draw a line across, you can see here we've got 37. So we've got over here 37 who took 90 minutes or less. So 37 take away 16, that's equal to 21. So here we have 21 people who took in between 50 minutes and 90 minutes. So if there's over here 40 people in total, of those 40, 21 took in between 50 and 90 minutes. So our probability is 21 over 40. Okay. Now for question 11, there are P counters in a bag and 12 of the counters are yellow. Shafiq takes at random 30 counters from the bag. 5 of these 30 counters are yellow. We have to work out an estimate for P. Well, if we compare the pieces of information here, assuming that we have a proportional sample over here that is taken out, you can see here 5 of the 30 are yellow, and if you compare that with what we have over here, we see that P out of 12 are yellow. So here we've got 1/6 multiplied by 12 equals P, so therefore P is equal to did this incorrectly. 12 of the counters are yellow, so here we've got 12 over P. So here we've got 1/6 equals 12 over P, so multiplying through by P, we've got P over 6 equals 12, multiplying through by 6, P is equal to 6 times by 12, which is 72. So there's 72 counters in the bag in total. Question number 12. T is equal to Q over 2 plus 5, and here is Spencer's method to make Q the subject of the formula. So first of all, he multiplies by 2, and if he does that, he's got 2 times by T equals Q plus 5. Well, that's straight away incorrect, because if he multiplies by 2, he has to multiply with the 5 by 2. So what mistake did Spencer make? He didn't multiply the 5 by 2 as well. So what we can say over here then is it should be, so they should say it, sorry. So it should be 2 times by T equals Q plus 2 times by 5. We have to multiply this 5 by 2 as well. So we end up with 2T equals Q plus 10, and if we rearrange for Q, Q is equal to 2T minus 10. This should be our answer. Okay, so now for question number 13 for part A, we have to write 5 over x plus 1 plus 2 over 3x as a fraction, as a single fraction in its simplest form. Well, what we can do here is cross multiply. So we have 5 times by 3x lots plus 2 lots of x plus 1, and on the bottom we end up with x plus 1 lots of 3x. And if we tidy all this up, on the top we have 15x plus 2x plus 2, so that's just expanding all the terms on the top, and on the bottom no need to expand all this. The reason for that is because we want this in its simplest form, so where we can, we factorise common terms. So on the bottom we've got 3x lots of x plus 1. So hopefully you can see here, all this simplifies to 17x plus 2, and on the bottom we've got 3x lots of x plus 1. Okay, so this here is our answer. And now for part B, we have to factorise x plus y all squared plus 3 lots of x plus y. And the way we can do this is to recognise that x plus y is a common factor. So we have x plus y, and if I multiply this by x plus y, this will get me the x plus y squared, and if I multiply x plus y by 3, we end up with 3 lots of x plus y. So this is our factorised expression. Okay, so now for question number 14, we've got the diagram over here which shows a right-angled triangle, and it has dimensions x minus 2 and x plus 4 centimetres. And the area of the triangle is 27.5. We have to work out the length of the shortest side of the triangle. You must show all your working. Well, the area of a triangle, that's equal to 1/2 times by the base times by the height. So here we have 1/2 times by the base. The base here is x plus 4. Times by the height here is x minus 2. And this is equal to 27.5. 27.5 is the same as 55 over 2 as a fraction. So if we multiply all terms by 2, we have x plus 4 lots of x minus 2 equals 55. And if we expand and simplify the left hand side, x times by x gives x squared, x times by minus 2, that gives minus 2x, and 4 times by x, that gives 4x. So minus 2x plus 4x, that's 2x. 4 times by minus 2, that's minus 8. And if I take this 55 over to the other side, you can see x squared plus 2x minus 8 minus 55 is equal to 0. Now if we tidy all this up, we have x squared plus 2x minus 63 equals 0. And if we factorise this, we have x minus 7 lots of x plus 9 equals 0, from which we can see x is either equal to 7 or minus 9. And clearly we need to reject this minus 9. The reason we want to reject it is because length can't be negative. So the shortest length, if x is equal to 7, this length over here is going to equal 7 plus 4, which is 11. This length over here is equal to 7 minus 2, which is 5. Of course, this length will be the longest side because of Pythagoras. So the length of the shortest side, that's equal to 7 minus this 2, which is equal to 5. So we have here 5 centimeters. Question 15, we have to express 0.418 as a recurring as a fraction. You must show all your working. Well, if we let x equal 0.418 recurring, so the 1 and the 8 are repeating. Okay, so we can continue it like this. Because we have 2 digits which are recurring, we multiply this x by 100. So we have 100x equals 41.818. And we can continue. But essentially, you can see if we subtract these equations, 100x take away x, that's 99x. And if we subtract 41.8 etc. minus 0.4 etc., you see all these terms over here will cancel out. So we have 41.8 take away 0.4, which is 41.4. Okay, so if we now solve for x, x is equal to 41.4 over 99, Of course, we don't want any decimals, so we need to multiply the top and bottom by 10. So we have 414 over 990. Question 16. For part A, we have to rationalise the denominator of 22 over root 11. Give your answer in its simplest form. So we start off with this 22 over root 11, and we need to multiply both the numerator and the denominator by root 11. So if we do that, 22 times by root 11, that will give 22 root 11. Root 11 times by root 11, that gives 11. 22 over 11, that gives 2. So we end up with 22 root 11 as our final answer. So we have 2 root 11. And now for part B, we have to show that root 3 over 2 root 3 minus 1 can be written in the form a plus root 3, where a and b are integers. So to do this question, we would have to multiply the top and bottom by the conjugate of the bottom. So we have root 3 over 2 root 3 minus 1. We need to multiply both the top and the bottom by the conjugate of the bottom. So what that means is we need to change this minus to a plus. So we multiply top and bottom by 2 root 3 plus 1. And if we multiply this out, well, 2 times by, if we write it out in full actually, we have over here root 3 times by 2 times by root 3. So we have 2 times by root 3 times by another root 3. And then root 3 times by 1, that's just root 3. And on the bottom, 2 root 3 times by 2 root 3, that's 4 times by root 3 times by root 3. And minus 1 times by 1, that's equal to minus 1. Of course, we've got a difference of 2 squares on the bottom. And if we tidy all this up, 2 times by root 3 times by root 3, that's the same as 2 times by 6. So we've got 2 times by 6 plus root 3 on the top. And on the bottom, we've got 4 times by 3 minus 1. So we end up with 12 plus root 3 on the top. And on the bottom, we end up with 11. So this over here is our final answer. Question 17. A and B are two similar cylindrical containers. The ratio of the surface area of A to the surface area of B is equal to 4 to 9. Tyler fills container A with water. She then pours all the water into container B. Tyler repeats this and stops when container B is full of water. We have to work out the number of times Tyler fills container A with water. You must show all your working. Well, we see that the ratios of the area scale factor, that's equal to, well, A to B, that's equal to 4 to 9. So in terms of the length scale factor, the ratio of A to B, square rooting, we end up with 2 to 3. And therefore the volume scale factor, the ratio of A to B, cubing the 2, we end up with 8. Cubing the 3, we end up with 27. So the volumes of A and B are in the ratio 8 to 27. So the idea is over here, we fill this up fully, and then we pour this into B continuously up until there's no more space. Now, over here, it doesn't matter what the volume is. The idea is over here, whatever volume we have, we multiply by 8, and here we multiply by 27. So essentially, we're trying to figure out how many of these 8s fit into this 27 over here. So you can imagine, if we fill as necessary, we've got over here 1 lot of 8 litres, 2, 3, and there'll be a bit left over like so. Okay, so essentially we have 27 over 8, which is 3.375. So therefore, we would have to fill at least 4 times. Okay. Question 18. A function f is given by 2x cubed minus 4, and we have to show that the inverse of f of at x equals 50 is equal to 3. Now to do this question, because if we substitute in the inverse of f into f, we get x. This is just a common fact. And therefore, what we need to do over here to find out what f of minus 1 at x equals 50 is, we have to let f of x equal 50, because the inverse is a reflection in the line y equals x. So we have 2x cubed minus 4 equals 50. So 2x cubed is equal to 54. X cubed is equal to 27, and therefore x is equal to 3. And that's what we wanted to show. And now for part B of the question, the function g and h are given by g of x equals x plus 2 and h of x is equal to x squared. We have to find the values of x for which h of g of x is equal to 3x squared plus x minus 1. So we have to substitute in the x plus 2 for x in h. So here, h of g of x, that's equal to x plus 2 all squared. So we substitute in the g into the h. So this here is h of g of x, and this is equal to 3x squared plus x minus 1, and we have to find the value of x. So first thing, expanding, x squared plus 4x plus 4 is equal to 3x squared plus x minus 1. Tidying everything up by taking everything over to one side. 2x squared minus 3x minus 5 is equal to 0. And for us to solve this, we need to factorize. So we need two numbers which multiply to give 2 times by minus 5, which is minus 10, and which add to give the minus 3. You'd find those two numbers to be minus 5 and 2. So we have 2x squared plus 2x minus 5x minus 5 equals 0. So if we factorize the bit on the left, we have 2x lots of x plus 1. We want an x plus 1 here, and x plus 1 lots of minus 5 gives minus 5x minus 5. And if we group all the terms together, we have 2x minus 5 lots of x plus 1 equals 0. So if we solve for x, you can see here x is equal to 5 over 2 and minus 1. So we have here x equals 5 over 2 and minus 1. Question 19. Given that 9 to the power of minus 1/2 equals 27 to the power of a quarter divided by 3 to the power of x plus 1, we have to find the exact value of x. So to do this question, we would have to write everything so our base number is 3. The reason we want to do that is because if we then compare powers, it makes our life easier. So 9 we can rewrite as 3 squared. So we have 3 squared to the power of minus 1/2. Of course 3 squared is 9. This is equal to 27. Now 27, that's the same as 3 cubed. And we raise this to the power of 1 over 4. And then we divide this by 3 to the power of x plus 1. So what we can now do is compare powers. Well, let's tidy all this up first. We have to use the law over here that, first of all, a to the power of m to the power of n is equivalent to a to the power of m times by n. So 3 to the power of 2 to the power of minus 1/2, that's the same as 3 to the power of 2 times by minus 1/2, which is minus 1. And this is equal to 3 to the power of 3 times by a quarter, so we have 3 quarters. And then we divide this by, well, we'll write it like this. We divide this by 3 to the power of x plus 1. Now, whenever we divide powers, a to the power of m divided by a to the power of n, that's equivalent to a to the power of m minus n. We subtract the powers. So here we have 3 to the power of minus 1 being equal to 3 to the power of 3/4 minus x plus 1. So now if we compare powers, so now comparing powers, we see here we have minus 1 being equal to 3/4 minus x plus 1. And if I multiply this minus 1 into the bracket, we have minus 1 equals 3/4 minus x minus 1. And hopefully here you can see the minus 1's cancel on both sides. So we have here 0 equals 3/4 minus x. In other words, x is equal to 3/4. Question number 20. The graph of y equals f of x is shown on the grid over here, and for part A on the grid we have to draw the graph with the equation y equals f of x plus 1 minus 3. And straight away you should be thinking to yourself in terms of a series of transformations. This over here is a translation by vector minus 1 minus 3. So we need to move each of these points minus 1 across and minus 3 down. So if we consider this point, moving it one place to the left and 3 down, it now goes over here. So then we copy out the shape, there's no stretches involved, which makes our life a bit easier. So we have something looking like this. So then we got 2 down, 1 across. So let's just draw this on. And then we go here 3 across, 3 up. So 1, 2, 3, and then 1, 2, 3. So that goes here. So join these up. And then here we go 2 across. So this is the graph y equals f of x plus 1 minus 3. Okay, so now for part B, the point A with coordinates minus 2, 1 lies on the graph of y equals f of x, and when the graph of y equals f of x is transformed to the graph with equation y equals f of minus x, point A is mapped to point B. We have to write down the coordinates of B. Well, going from y equals f of x to y equals f of minus x, straight away you should be thinking to yourself, this is a reflection in the y-axis. So if we reflect in the y-axis, the x-coordinate changes. So currently we've got this point A, and if we reflect it in the y-axis, the point B over here has coordinates 2, 1. So therefore we have 2, 1. Now question 21, we have to sketch the graph of y equals 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intercepts with the coordinate axis. Okay, 21, sketch the graph of y equals 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intercepts with the coordinate axis. Okay. Now, because it says turning point, that suggests to us that we have to complete the square. Now when we complete the square, we're going to end up with y equals something looking like p lots of x plus r all squared plus q. Okay, and over here, the coordinates of the turning point would be minus r, q. And for us to get this into this form, we would have to complete the square. And that can help us actually to solve the equation, because if we solve the equation, that helps us find the exact coordinates of any intercepts with the coordinate axis. Now, first thing we can do is find out where it intercepts the y-axis, and that's quite easy. We simply set x equal to 0. And if we set x equal to 0, we have y equals 2 lots of 0 squared minus 8 lots of 0 minus 5, which is minus 5. And now when y is equal to 0, we're going to have 2x squared minus 8x minus 5 equals 0. Now, if we complete the square, first thing we need to do is take out the 2 from the first two terms. So we have 2 lots of x squared minus 4x, close big bracket, minus 5, this is equal to 0. And the reason I want to do this is because I can now complete the square of this big bracket. So if I complete the square of the big bracket, we have the coefficient of x, so we have the minus 4, which is minus 2. So we have x minus 2 all squared minus the square of minus 2, which is minus 4. And then we still subtract off 5 and all this is equal to 0. And if we expand out, we have 2 lots of x minus 2 all squared minus 8 minus 5 equals 0. So we have 2 lots of x minus 2 all squared minus 13 equals 0. Now the reason this will help us is because if we compare this with what we had over here, you can straight away see that the coordinates of the turning point have coordinates 2 minus 13. Our next couple of steps is to simply solve this equation and rearrange for x. So if we do that, we have x minus 2 all squared equals 13 over 2, square rooting. We have x minus 2 equals plus minus 13 over 2 square rooted. We don't need to simplify this, there's no point. And therefore x is equal to 2 plus minus 13 over 2 square rooted. So if we now sketch the graph, well, first of all we also need to look at the shape of the graph. Because we have a positive quadratic, we have a U shape. So if we sketch the graph, we draw on some coordinate axis like so. We have y, and then we have x, and the graph will look something like this. So here is the coordinate. Let's do it in a different colour actually. Let's do it in green. Here we've got the coordinate 0, minus 5. Here we've got the turning point at 2, minus 13. Here we've got x1, which is 2 minus root 13 over 2, and the y coordinate is 0. And here we've got the other coordinate, 2 plus 13 over 2 square rooted 0. So this over here is the graph of y equals 2x squared minus 8x minus 5. So that was actually quite hard for 5 marks, I thought. This is an A-level question. But now for the next question, we've got A, B, C and D, which are 4 points on a circle, and AEC and DEB are straight lines. We've got an equilateral triangle in ADE. So if we've got an equilateral triangle, let's just annotate this as we're going along. We've got 60 degrees here, 60 degrees here, and also 60 degrees here. And this length is equal to this length, which is equal to this length. And we have to prove that the triangle ABC, so ABC, that is this triangle here, so this is ABC. We have to prove that this over here is congruent to the triangle DCB. So DCB, that is this triangle over here. So when we talk about congruent triangles, we want to show that they're the same. Okay. So the first thing we can do is recognize that, if we go back here, ACB and ADB are the same. So ACB, that's this angle here, is the same as ADB. Yeah, that makes sense. And the reason for that is we have alternate angles. Okay, so let's just write that down. ACB is equal to ADB, and DBC, so that's this angle here, is the same as the angle DAC. So DAC, that's this angle here. Okay, so let's just write that down. DBC is equal to DAC, and we've also got ABD. So ABD, that's this angle here, is the same as the angle ACD. That's this angle over here. And the reason for that is we have angles in the same segment which are equal. So we have here ABD, which is equal to ACD. And what we also see is DCB, so DCB, that's this entire angle, is the same as ABC, which is this angle over here. Okay, so let's just write this down. We have DCB, which is equal to ABC. So the reason for all these is that angles in the same segment are equal. So what this means then is this angle over here in green is equal to 60 degrees. This angle here is also equal to 60 degrees. And because angles in a triangle are up to 180, this angle over here is also 60 degrees. But there's another reason this is 60, is because we have vertically opposite angles. So that angle, which is CEB, so CEB is equal to DEA, which is equal to 60. Vertically opposite angles are equal. Now, what else we can see about those triangles? The length BC is common to both. Okay. So, what else can we say from this? DB, so DB, that's equal to, well, DB, that's, what can we say about this? Okay, so if this angle over here, if the angle ABC is equal to the angle DCB, and if also this angle is 60 and this angle in blue is also 60, because angles in a triangle add up to 180, this angle and this angle will be the same. And that makes sense because, again, we have alternate angles in the same segment. So what we have over here is CDB. So CDB, that's going to equal the angle CAB. Okay, and therefore from this it follows that DB and AC are equal. So therefore, because the triangles are essentially congruent, so therefore DB is equal to AC. Okay, and what we can therefore say from here, DB we can split up as DE plus EB. So here we have DE DE plus EB is going to equal, well, AC we can split up as AE plus EC, so AE plus EC. So what we mean by this, well, here you can see we've got an equilateral triangle, so this is equal to this, which is equal to this. What we can see from here then is EC is equal to EB then. So so if we write that down, we have EC, so EC is equal to EB, and well, in conclusion, we can see therefore we have side angle side, and therefore the triangle ABC is congruent to DCB. Quite a hard question that I thought, but I hope that helped.